Okay, so everybody, welcome one more time. Welcome. This is a April, May, March, April, May. Oh my gosh, it's school year's almost over. This is March, the Steam Day for March. We are going live on robotics and working with Mr. Barnaby. He's been here before. He brings a plethora of information to this and knowledge. So if you have any questions, we're gonna be learning about robotics as your Steam Day. You all have your kits that were sent out via the PA Smart Grant that everybody received. We'll be working on the same kind of thing. Mr. Barnaby, if you have any questions for him, just unmute yourself, ask the question, get an answer, or you can type it in the chat, and then Mike, the remote control icon avatar, will respond via chat. So that's kind of what he does. So students today, you guys are gonna basically just get to creating. Next month, we will be doing garage band music creation, song creation, actually making music in iPad. And then May the 4th, we have a special day on cosplay, creating lightsaber hilts, like the handles for a lightsaber. So that'll be May the 4th if you're interested in that. So that's what's coming down the line. And without further ado, Mr. Barnaby, drum roll, please. After you, buddy boy.
All right. Hey, welcome everyone. Thanks for being here on this Easter weekend here with us. So I'm Chris. Josh was calling me Mr. Barnaby. Don't call me Mr. Barnaby. Just call me Chris. As Josh said, as we're working, if you have any questions at any point, please just unmute, interrupt. It's going to be a very active session. We're going to be up and out of our seats. We're going to be making messes. But it's all going to be good. It's all going to be fun. So I'm not going to have my eyes on the chat. So if you do have a question, please just unmute and ask your question. And like with a hands-on session too, it's helpful. Like, thank you for having your cameras on. That's helpful for me to see what's going on and where you're at. So what we're doing today, we're going to be using our Hummingbird robotics kits. We're going to be using a lot of craft supplies, and basically we are going to call this project, let me share my screen, the Robot Petting Zoo. And you're going to be making, I'm going to show you an example. My daughter and I, my daughter's 8, we made this week to kind of use as an example of my robot petting zoo. So this is Buddy. Buddy the beaver, and this is what Buddy does. So let me start it real quick. Oops. All right, can you all see him? Okay. So basically what happens is whenever you feed Buddy beaver food or robot food, which is just cardboard, he responds by blinking his eyes and kind of thumping his tail. So that's the robot that I made for this project. So just to give you an example, but you can make, it's kind of totally up to you with what you want to make and what you want to build. So you could stick with, just take a minute now, kind of let's think about what we want to create. You can create an animal that responds, or, if we want to keep it with like a video game theme, you could also create maybe a character from one of your favorite video games or movies, whatever you like, but some parameters with your robot. Okay. So number one, all robots take an input. Okay. So there has to be something that triggers an action. Okay. In the case of Buddy here, let me pull it up. Our input is going to be food. But what I'm going to show you here in a minute is that there is a sensor inside Buddy's mouth, a light sensor inside Buddy's mouth, that when it casts a shadow, when there's a lack of light, it's going to then trigger an output. Okay, that's the second part that a robot needs. So a robot needs an input, something to initiate action, and then it needs an output. It needs an action to respond to that input. Okay. And I have two outputs with Buddy here. So one is the eyes rolling. Okay. And that uses a servo motor. And then the second output would be the tail wagging for it. So I actually have two servo motors. But just to let you know, so I used a light sensor for my input. You're going to have a couple options, which we're going to go over. And then for my output, I used a servo motor. But you also have a couple options there. So you could, if you didn't want to use a motor, you could also have light as an output. You can have LEDs light up in a certain way. So what we're going to do here in a minute is we're going to dissect Buddy so that I can show you how my daughter Avi and I built him. But before I do that, I do want to maybe show you a couple of examples, actually off of the Hummingbird website, of some different animals that they created and some different ways that they did their inputs and they did their outputs. Okay, so I'm going to stop sharing my screen for a second. Okay, so I'm going to play, if you can see my screen here, I'm going to play part of a video here from Hummingbird. So you saw mine. So mine takes a light sensor. So whenever you feed Buddy, it triggers the motion. So this example here, this is a chameleon that this woman built that basically the input is rather than a light sensor, it's a distance sensor. So whenever you get close to the chameleon, as chameleons do, it's going to change color. So in this case, the input is a motion sensor. So whenever something is close, and then the output is a change in an LED color. And that looks like this. So again, just a different example how they did inputs and outputs.
When I get close to the chameleon, it turns pink to blend in with the flower behind it. Let's take a look at how to.
Okay, so as you saw there, like when you're away from the chameleon, it's one color. When you get close to it, it changes to a different color. Another example is actually an anglerfish. So this is similar to the one that I created. It's going to use a light sensor as an input. And then it's also going to use a servo motor and a mechanism called a crank to open and shut the mouth, which is what I actually used on the tail. But they do the light sensor a little differently. So they actually had the light sensor on the head of the anglerfish. So when you go and pet it, it's going to cast a shadow, which will then trigger the motion.
Because anglerfishes do not like to be pet. So to explore how those two eyes turn angry and the mouth tries to bite you, because anglerfishes do not like to be pet. So to explore how those two.
Okay, so there's two examples of some different inputs and outputs that you could do. It might be useful. Maybe can we take a couple minutes? I see there's a few people in the room. Maybe we could discuss, and maybe before we dive in and before we dissect poor Buddy here, and take him apart, maybe do you think we can take a couple minutes, discuss with each other? And by the way, too, this is a good project if you want to work with a partner. This would be a good partner project to buddy up, maybe groups of 2 or 3 if you wanted to. But maybe get together and talk a little bit about what you want to make, what you want to create. And again, so like I kind of stuck with the animal theme, but you don't need to go there. You could also do, a video game character, whatever you want to create, but it does have to respond to a stimulus. It has to respond to a human, and then it has to produce an output. I should also mention too, and I didn't show this example, another input that we could use is actually sound. So like you could, and I showed this if you were in the first session, we do have a sound sensor, but you can have your robot respond to sound too as well. So keep that in mind. But maybe let's take like 3 or 4 minutes, maybe discuss with yourselves. And then if we could do like a share out of what ideas that you have that you want to create. So think about what you want to make, whether animal or character, and then what's going to be your input and what's going to be your output.
We need cardboard for this.
Yes. Oh, well, it would be helpful to have cardboard.
Okay.
So probably while you're discussing, I think it would be helpful, like craft supplies that you can have together would be very helpful. So cardboard, hot glue guns, popsicle sticks, paper clips. Okay, whatever scrap that you have around would be really helpful. Okay, so can I hear from the libraries here? So what are we thinking about what we want to create? Have we, and what our inputs and outputs are going to be? So have you guys come up with any ideas of what you want to make?
So for our groups, we are making a turtle and we are making a dog.
Nice. So with the, can we talk about what you're thinking about for your input and your output?
Yeah, what are we thinking about for inputs and outputs? Okay, we're gonna make the turtle move its head into its shell.
Okay.
And then what are we thinking for your dog?
It will like to the wheels.
Okay,
Then when it puts it up to when it uses something.
okay, cool. So our dog is gonna have wheels on it, and then whenever like a person approaches it, it's gonna start rolling away.
Okay. All right. So it sounds like for the dog, our input is going to be a motion sensor. And then whenever
Yeah.
someone gets close, the output is going to be a rotation server. I have one here that's going to turn, or two rotation servers probably that need to turn wheels that will make the dog move away. Okay.
Yeah.
So the turtle, if we can talk about that. So our output for the turtle is going to be the neck goes into the shell.
Mhm.
Okay, so for that, we're going to use a position servo. What are we thinking for the input for the turtle? What's going to prompt that? Is it when you
Just
try to pet the
whenever
turtle?
anyone like approaches it, it'll. Oh, so it's gonna be a light sensor that
Okay.
will
So like when you try to pet it or
yeah.
Okay.
Yeah.
okay, awesome, awesome. Okay. How about can we hear from Shippensburg? What's Shippensburg thinking about doing?
Sorry, so we have come up with, one of them has come up with a really horrifying dog that I don't want to include. I'm really praying I can convince him not to do. What else have we come up with?
Enderman.
What is that? Oh, something for Minecraft, an
Okay.
Enderman. Enderman, sorry, I'm not really well versed in Minecraft. What else was it? A regular normal dog that doesn't strike fear into everyone's hearts.
Yeah, all right, it's a friendly dog. All right, so can we start with the dog? So can we talk about what we're thinking about for an input and an output for the dog? And it doesn't need to be complicated. Like you could do a simple wag of the tail when you try to pet it.
They're gonna have its ears move up and down.
Okay. Okay. And what's going to prompt? So that's the output. The ears are going to move. Okay. So what's going to be the input? It's going to prompt it.
Pet it on the head.
Okay. So for that, we'll probably use a light sensor. So when you try to pet it, it'll make the ears move. Okay, perfect. Now, how about Minecraft? What are we thinking for an input and then for an output?
Just when you try to get near it, like apparently they move their arms when you move towards it.
Okay. All right. So our input, it sounds like we're going to use a motion sensor for our input. We could probably use a light sensor too. It depends how close you want to get to it, but probably a distance sensor, a motion sensor, and then that's going to be our input, and then the output we'll use position servos to move arms or not. Okay, perfect. All right, so to give you some ideas of how to, so I'll start, we'll talk about like the mechanical side first, and then we'll get into the coding of it, okay? So again, right now I'm going to share my screen, and we're going to dissect poor Buddy here. just so I can show you my setup and how I did it, and how I have things set up. So, and to give you ideas of how you can build this. So, and some different mechanisms that we can use and things like that. Okay. All right. So here we have Buddy. Let's take him apart. I'm going to get out of my chair a little bit and just bear with me. I have to move around and kind of navigate. I don't have a whole lot of space to work with. All right. So let's take Buddy apart. So first, I'll actually run the code so you can. Okay. So if we look inside Buddy to see what's going on, okay, we're going to start with our inputs here. So what we have for my input is I'm using a light sensor right there. So you can see the light sensor is on the bottom. Okay, and I'll give you a close-up view of what that looks like. It looks like I have some tape around it now. Okay, but that is our light sensor. So that's going to measure light in a certain space. And my input, I wanted to be like when we fed Buddy. So we need to interrupt light. Now, the problem is if you have the light sensor inside of a mouth, there's not a lot of light in the mouth. So I had to create that light by making this green LED, right? That as the program is running, this green LED is constantly shining onto the light sensor until a piece of food comes along and interrupts that. Okay, so that's how I did it. Again, it looks like a couple of you, sounds like a couple of you are going to be using light sensors. You don't have to have it. So this would be a useful thing if you want like a animal to be fed. If you're keeping that light sensor on the top of your animal, and just when you pet it, you can see like how it casts a shadow. You don't need to have that light constantly shining because you're going to use the light in the room. Okay, if that makes sense. Okay. Those of you, it sounds like a couple of you are going to be using the distance sensor. So let me get that out real quick so I can show you what that looks like. Okay, so your distance sensor is going to look like that. And basically when we code this, it's like how far away something it gets to this. And it's going to detect motion, but it's kind of like there's little cameras in this. Okay, so as you're, so talking about input, so it looks like all of us have either a light sensor or a distance sensor for our input. Just be thinking about as you build and as you're planning this, where are you going to place that sensor? So that's one of the most important things, a good placement for that sensor so that it can detect what it's doing. Okay. So that's how how I set up the input for Buddy here. Now let's talk a little bit about our output options. Okay, so I use two position servos. So keep in mind we have two different types of servos that we can work with. So one is get into view. One is a rotation servo, and you can see there's kind of a symbol. This would be our group that wants to make the dog on wheels. This is the kind of servo that you're going to be using. So this is going to be a continuous 360-degree turning servo. Okay, so again, rovers, cars, things like that, things on wheels. This is the kind of servo that you want to use. Now the servo, I think the rest of us are going to be using and what I used is a position servo. Okay, so these are different than the rotation servos. These move from 0 to 180 degrees like this. Okay. With these kind of servos, one thing I will say, you have to be careful of where you place them. And I'm going to show you that here in a minute. Make sure they're turning in the right direction that you want them to turn. They don't turn in a negative number. It goes 0 to 180. All right, so let's kind of take that apart and talk about my output. So the first one I'll talk about is the eyes. So I made kind of a little mechanism. I'm going to stop that for a minute. So let me kind of take this apart. Okay, so hopefully we can see that. This is my position servo that I use to move the eyes. And here's my eyes right here. Let me hide my code. There you go. Okay, so what I did to place my position servo is I cut out a hole. You can kind of see in the back, I cut out a hole that my position servo is just going to fit in. To do that, I had to trace along, trace the shape of my servo, which I think some of you are going to have to do. Now, let me show you kind of a little tip for tracing. If you need to trace out a cutout for your servo, let me show you that real quick, because there's something you need to keep in mind if you're going to do that. Okay. So let me put this into view. If I'm tracing out a notch for my servo, I'm just going to do this real quick. Like this. Okay. So I traced it like that. What I want to make sure that I do when I cut this out of cardboard, I want to make sure that I'm cutting on the inside of the marker line, not on the outside. If you cut on the outside, that's going to be too big and your servo is going to fall right through. So make sure after you trace out your servo, cut on the inside of the lines. You want it to be tighter. So that's a little tip that I learned the hard way. But something to keep in mind. Okay. All right, so that's how I kind of fixed my position servo in there. Let's talk about the mechanism that I used to make the eyes roll. So first of all, my daughter kind of drew these eyes on the position servo. We made sure that they lined up with the openings on Buddy right here. So you can see we have eyes. This would be kind of the mode where the eyes are open. Then above that, just a solid like rectangle, that is eyes closed, right? And then it turns back and forth between the two. Okay. And then what I did, so I just used a toilet paper roll to do that. And then I created a simple mechanism called a wench. Okay, and you can see I took kind of the star servo horn there, and I just hot glue gun like a piece of circle cardboard, and then I hot glue gunned the toilet paper roll here, and then that fits on the servo like that. Okay, and then it rotates. Okay, so that's the first mechanism I want. So that's first output, okay, that we created. Then the second output, okay, was the tail, the beaver tail. So if you can see in here, what I did, I hot glue gunned, and you can hot glue gun onto the servos. Okay, sometimes I like to put like a piece of tape before I hot glue gun on them, but I hot glue gun that this servo to the top to kind of secure it into place. Then I created a mechanism called a crank. Okay, so I made like a little arm with a piece of cardboard and I glued a paper clip on it. And then I attached that to the tail. Okay, so that it can go back and forth. You can see like when I did mine, there's not a lot of mobility here. Like I cut this tab out of the back of it. Okay, it's kind of rigid like that. So if you're going to use something like a crank, I would use the flaps of a box because those are already folded and pretty flexible. And I think it'll work out better. So I kept on running into problems with this cardboard arm of the cardboard like bending and tearing just because this flap was so rigid. Now that would, just to keep in mind, this was a more complicated way for me to make the tail wag. An easier way would have been me to just notch out a space for the servo and then attach the tail to a servo horn and onto the servo and just have it wag left and right, back and forth. That would have been an easier way to do it. But I did it a little bit more complicated by making that winch and that mechanism there. Okay. So those, that's how I did my inputs and my outputs mechanically. So now what we can do is dive in a little bit to the coding. If you want, let me plug got my servo in. Let me get my wrench on here. Okay, and then we can talk about how I coded this. So before I get into the coding, do you guys have any questions with, and hopefully that's giving you some ideas of, where you're going to place your servos, where you're going to place your sensors. Any questions so far or anything dealing with like your specific project that you might have at this point? Okay. All right, so I tell you what, before we move into the coding, so can I get some feedback from where you guys are at before I talk about coding? Would you like just a little bit of time just to start building and like figuring out where you're going to place like the sensors and where you're going to place the servos? Would that be helpful? I don't want to move too quickly or get ahead of myself here.
Yeah, that would be great over here.
Okay, we'll do that. So why don't we just, we'll take a break from me talking and let's have you guys just do some work. Let's take like 10 to 15 minutes. Start getting some things built. Start figuring out where you want to put your servos, your sensors, your lights, things like that. And then we can pause our work and then we can go on and talk about the coding part of this. Okay. Which I think actually the coding part, believe it or not, is probably the easiest part, but the difficult part is getting this built and everything. Hey, one little other tip I want to give you. Let me pull up my camera. If you're not a great artist like me, or don't have a lot of experience with creating art, so one thing that I did to make, you can see, or my daughter and I did. Now my daughter's, she's actually a pretty good artist and can draw pretty well freehand. I cannot. So what I ended up doing was getting you can see like Buddy here. I printed out a coloring page of a beaver. You can see it right here. And what I did was I just taped this coloring page onto the box, just taped it. And then what I did is, some of you might have done this too, like think if you, this is a common way that people carve out like jack-o'-lanterns. So what I did is I got a push pin, and then I just put holes and dots all around the box just to give me like a reference that I could trace on the cardboard. So that's kind of how we did it, my daughter and I. So just a tip, if you're not, strong at freehand drawing and you want to draw something, that could be a useful tip, just a push pin and like a coloring page or something like that. Okay, but let's take 10-15 minutes or so, just start building it out. Placing your servos and your lights, LEDs and sensors and everything. If you have any questions, just unmute.
So we have a question. How would we make something like come out of the box? Like out, like forward?
I would do, I'd probably do a crank. Okay, so let me get a couple pieces here to show you.
We also have a question here whenever you have a sec.
Okay. So what I would do is I would use a position servo. Okay. I would use like the round piece to attach to it.
I can't find the block that would control that's a sensor block. I can't find that block for a sensor.
Okay, give me 1 second. I'm talking to Shippensburg about a crank, and then I'll show you where that block is. Okay. All right. So what I would do is I would do a position servo with a round piece, and then I would make an arm. So you can do that out of cardboard. That's what I did with mine. So yeah, here we go. So you can use like a piece of cardboard or a popsicle stick. And
Okay,
you can hot glue gun. And then like if you attach a like a paper clip to this, and then attach the paper clip um to like the piece that you want to push and pull.
okay, thank you.
Yeah, that makes so basically like what a crank does, it pushes and pulls.
Oh, yeah, thank you for that.
Yep. So you kind of have an idea of where to go now?
Yep, okay.
Okay. Yeah, cardboard should work. Paper clips or popsicle sticks you can build a nice crank with. All right, Evans City. So we had a question about where to get the sensor block. All right, so if you are in Bird Blocks app, which I have on my screen, you should be under robots. Okay, and then what I'm grabbing is, did you guys want a light sensor?
We were looking for the distance sensor or the
Distance?
yeah.
Okay, so you would grab this light sensor here,
Okay.
and then where it says light, if you go into the drop down, then you can choose distance.
All right. Thank you so much for answering that.
Yeah, no problem. And we're going to here in probably about like in a few minutes, I'm going to go kind of in depth into how we're going to use that block and everything else. So
Okay, cool. Thank you.
yep. would you like another 5 minutes before we pause and go over coding? Looks like we're
Oh, yeah,
busy at work.
we definitely need more time.
Okay. Yeah, we'll take another 5 minutes before we pause. So I know we're still building. But would we be able to come to like a pausing point so that we can go over some of the coding here in about a minute?
Can we just like, get another couple of minutes and then then we'll do some coding? I don't know how they're doing in Evan City.
Yeah, I think they're still building to. How about like another 5 minutes? Is that good? So at 11:45, we'll pause. Okay. Thank you. come over? All right. All right, everyone. If we can come to a pausing point, I know there's still more work to be done as far as building, but we can pause so I can kind of show you the next steps to get this coded. And if you want to follow along with me, if you want to get out your sensors and servos that you're going to use, as well as your microbit Hummingbird board and your iPad 2 as well. Okay, so we're going to talk right now kind of the next phase, how to do this, like how we're going to do the programming for it. And really, I think this is, for me, this, I think this will be the easiest phase. Really, the bulk of the work is getting everything built, getting everything in place. And I'll also add too, if you don't get this all the way done, or to the point where you want it to be at the end of our session, that's okay. This is something that you can always come back to later. We're holding another session next Saturday. You can feel free to join us and continue working on it now. So if we don't quite finish today, that's okay. You can always come back to it. All right. So right now, what I want to talk about is getting everything programmed and hooked up. So before we jump into the code, let's talk about our Hummingbird boards and how we can set this all up in case you haven't done that before. Okay, so I'm gonna bring my camera back up. All right, so first, let's dive into and take a look at our Hummingbird boards to see how this is all set up here. Okay, so I have a sample Hummingbird board here. If you were at our last session, we kind of talked about this. So this right here is really the brains of the whole operation. That is our microbit. So essentially what this is like a $15 to $20 computer that was made by Microsoft and the BBC. So actually, a little fun fact, in Great Britain, in the United Kingdom, a lot of students in middle school are actually required to carry these around with them at all times. It's part of their computer science education initiative. But yeah, this is a little $15 computer that you can code to do all kinds of things. With this, you have a couple options. You have buttons on the front to respond to inputs. You have a panel of LED lights right at the front. These LED lights can also serve as a light sensor. You also have a couple sensors built in, like an accelerometer. You can program this to detect if it's moving. A magnetometer, so it can detect, kind of act like a compass if you wanted to. But this alone only has so much functionality. So that's why we have, these are called breakout boards, and there's a couple different types. The type we're using is called a Hummingbird, which when you plug in your microbit to this, it just extends the capabilities of your microbit. Your Hummingbird boards do need a power source. So if you have a barrel connector with AC power, you can use that, or they also come with a 4x AA battery power pack. So you can plug this into battery power as well. And if you use the battery power pack when you're ready to use it, keep in mind on the back, there is an on and off switch on the back for that. Okay, and then on the Hummingbird, this is where you can kind of plug in the elements that you need. So first thing I plugged in was an LED light. Okay, and you have two types of LEDs or lights. You have tricolor, which will give you, multicolor, red, green, blue, but you can combine those to create other colors too as well. And then you have just your standard LEDs, which is what I have plugged in right now. So this one will give a yellow light. Very important with anything that you plug in, keep in mind your ports are numbered. Okay, so right now I have my LED in the number 1 LED port. Okay, so that's going to come in handy, like just keeping that in mind. And I would start with number 1, then move to number 2, and then number 3, and build out from there. But when I do my programming, I'm going to have to tell my code, what port do I have that LED plugged in, or the light sensor plugged in, or the servo. To plug these in, just show you real quick. This is where it's useful to use this tool to get your wires. You can see there's buttons on here that you can use the tool to press in. And this is how you can plug in and unplug your wires. Okay, kind of like that. But that could take a little bit of getting used to. Takes a little bit of dexterity to use. When you're plugging in these wires, just a couple things to keep in mind. Like with the LEDs, you can see there's a positive and then there's a negative. So the black wire, your black wire is always going to be your negative. Okay, so if you can remember that, you should be able to figure out everything else, but your black wire is always the negative. And then with your standard LEDs, the positive is just going to be a different color than black. Okay. If you have multiple wires, more than 2 wires, the positive they'll make the positive red. Okay, just as a standard point. Okay, now to your servos. So you have 4 ports on here to plug in your servo motors, whether that be a position servo or a rotation servo. Like the LEDs, so these are kind of easier to plug in because you don't have the exposed wires. They have that piece on the end. But just keep in mind, you just want to line up the black wire with negative, because that black wire is going to be your negative connection. And then you could plug that in again. But again, especially if you're using multiple servos, just keep in mind what servo is plugged into which port. Okay, because that's important for the coding. Last thing, you have a panel for your sensors. And again, in this case, I have plugged in a light sensor. Again, negative is black, positive is red, and then the other color is S. Okay, so if you're using a light sensor, you want to plug that in. If you're using your distance sensor, you could plug that in just like that too. Okay, but that's kind of the setup for our Hummingbird. And getting everything plugged in. Any questions as far as plugging things into the board or setting up your Hummingbird board at all? Okay. So now what I'm going to show, we're going to jump into the coding part. Okay, so once you have your Hummingbird board plugged in, your microbit in, make sure it has power. You're going to launch in your iPad the Bird Blocks app, which is going to look like this. You want to make sure in this menu, there's Hummingbird has a couple different products. We're using the Hummingbird bit for ours. So that's where we're going to be taking blocks from. And when you have your microbit plugged into your Hummingbird and it has power, you're going to see across the LEDs on your microbit, it should be giving you like a code, and it's going to be like 3 letters and like a number. That's the name of your microbit. So what you'll need to do is you'll need to connect. You can see mine's up here. Mine's already connected. But you need to go in and connect your iPad to that microbit, and it's a Bluetooth connection. So you might want to make sure, just some troubleshooting here, make sure that your Bluetooth is on with your iPad. So that needs to be on and able for these two devices to connect to each other. Okay. And then from there, you can connect it. If you have a connection, you're going to see here in the top right, there's going to be a green dot showing you that. If it's not connected, that will not be lit up. Okay. So at this point, if we want to, like, I'll give you like a minute. Let's go ahead, get our microbits and Hummingbird kits plugged in. Let's get those connected, and let me know if you have any issues.
Did these kits come with batteries?
No, they don't.
Okay, great. Well, then I have to find a bunch of batteries. There are no batteries in my office anyway. They won't know where to find. I can grab batteries. Hold on.
You can also use, if you have like an AC power with a barrel connection like this.
I'd have
That
a better
work as well.
connection in the library.
Okay, I think we might have gotten some batteries at Shippensburg. If not, that's okay. You know, just pause. We'll get caught up afterwards. So what we're going to do now is just go over some of the coding. So basically, I'm just going to walk you through like how I program mine, kind of step by step, and then you can kind of replicate it and modify it for yours. Okay. So again, at this point, I'm in the Bird Blocks app, right? I have I'm connected to my microbit right now. I have the green light on. So what I'm going to do now is, and I'm in the Hummingbird bit, and I'm under the robotics tab up here. So right now, I'm just going to pull out some of the blocks that I'm definitely going to need or use in my coding. Okay. So when I made Buddy, right, the first thing, let's talk about our input, right? So in order to get that input to work, I used an LED. Okay, so I'm going to drag in my LED block, and I did have that plugged into port 1. So I want to make sure I have port 1. Okay, and right now I'm going to keep it at 0%. Okay, so 0, it goes from 0 to 100%. 0 is off. Okay, or no power. Okay, so my next block that I'm going to drag in is my position servo. Okay, so I have my position servo right here. Again, I plugged that into port 1, so I want to make sure I have port 1. By default, that's at 90 degrees. We'll be adjusting that here in a minute. Okay, then the next thing I'm going to need is my light sensor. So that looks like this block here. It's called bit light. And even if you are using the distance sensor, you're also going to use that block as well. So if you use distance, you just go in the drop-down menu and you can choose distance from there. For my project, I used light, so I'm going to keep mine as a light sensor. Okay. So now what I'm going to do is I'm going to do these are the main 3 blocks that I need for my coding. And I'm going to test these blocks here right now. So what I'm going to do is I'm going to pull up my camera just so you can see how my project is going to respond to my blocks. Okay, so right now what I'm going to do is I'm going to turn on my LED. So to do that, I'm going to put in 100% for my LED. And then I'm just going to tap on where it says bit LED. I'm just going to tap on that block. And then hopefully you can see that turned my LED on inside of Buddy's mouth right there. Okay. So next, okay, I'm going to test my light sensor, see if my light sensor is working. So again, here's my light sensor. If I click on bit light right there, that should give me a number of how much light is that the sensor is picking up. So if I click on that, you're going to see right now 65. So that's the number. It seems a bit low. I think that's a little out of place. Try this again. There we go. That's a little bit better. So right now I'm at 91. My light level is at 91. Okay. However, I can test this out if I give it some robot food and block that sensor. And then if I tap on that again, you're going to see that falls to 0. Okay. So again, all I'm doing right now is just testing out my sensor and testing out that light level. Because that's going to be important, because when I code this and I want to say the light is blocked, I want to choose a number kind of in between. I'm at 88 right now, in between 88 and 0. Okay. All right, then finally, the next thing I want to do is test out my servo. So right now it's at 90 degrees. So if I press that, okay, and tell you what, actually, I'm going to do port 2. So right now, my servo is at 90 degrees. If I change this, let's try 0 degrees. Okay. Right now, my servo is at 0 degrees. Is there a question?
We were kind of lost. We were having trouble connecting and we weren't really paying attention. So
Okay.
we
Okay.
don't really know.
All right, I'll back up a little bit. All right, so first thing to get this, so let's talk about getting this connected, okay? So first thing, you need your, if you can see me, you're gonna need your microbit plugged into your Hummingbird, bit like this, and then you're going to need power going to that. And when you have that, it should, your microbit will need to look like this. Let me pull up your camera. You should see, if you can see my microbit in there. Okay, you're going to have some like 3 letters and a number flashing across the screen when that has power. Do you see that?
Yeah, we have that.
You have that?
Yeah.
Okay, perfect. So just let that flash, let that go. Okay. Are we okay? Okay. All right. So while that's flashing across your microbit, that means that it's ready to be paired with your iPad. Okay. So then what you'll do is you're going to launch the Bird Blocks app. Okay. If you see like a list of devices here, you want to choose the open up the Hummingbird bit blocks. Okay. And then to get it connected, it's up in the top left. Okay. You'll see this bird with like a chain right here. You want to press on that. Then you're going to choose connect device. And then hopefully you're going to see that microbit. Now there might be several microbits trying to connect. So just make sure you select, and so you might see all the microbits in the room. Make sure you connect it with the code that's coming on. So like the letters flashing on my microbit were DPL. So I'm going to choose that. And then once it connects, you're going to hear like a little ding from the microbit, and then that will be green. I think I heard some O's. Is that a good sound?
We're all connected.
All right, awesome. Okay. So are you with me now? You should be in the Hummingbird bit. You should be under robots. And like I did, drag in the blocks that you're going to use. So drag in the light, the bit light, and then you can either change that to, I think there's one group using a distance sensor and one group using a light sensor from Shippensburg. But just specify that like distance or light. Also, too, I should ask Shippensburg, did you plug in your have you plugged in your sensors yet?
Yeah.
Yes? Okay. Okay, so again, like these are the blocks that I dragged in because these are the ones that I'm using. So like I needed the LED because that's what's shining on my light sensor. So I put in the LED one. I had that in port 1 and I turned that on to 100%. So when I click on this block, okay, my LED turned on when I clicked on bit right there. Okay. And then I'm using a position servo in mine. And I have 2 position servos. One is in port 1, one is in port 2. Right now I'm using the one in port 2. We're testing that out. Okay, so when I click on this block right now, okay, it just turned the servo to 0 degrees. But if I would put in 90 degrees and then click on this, okay, I don't know if you heard that or not, but it just rotated my servo to 90 degrees. Or if I change it back, now I'm back to 0. You with me so far? Okay. And then for my light block here, okay. So I'm using a light sensor. So if I click on that, it's giving me the light level that it's detecting right now. Okay. If you're using a distance sensor, if you have that hooked up, and if you like hold like your hand above the distance sensor and click on that, it should give you kind of like what it just did for me. It should give you a number for how far your hand is from it, and it's going to give it to you in centimeters. Okay, so I just wanted to go over that. That's how you can test your blocks, make sure everything's hooked up the way that it should be, and working. All right, can I get some feedback from you guys? Are you ready for me to show you the next phase of this?
So I've got everything hooked up,
Okay.
and then I have,
Yeah, we're
Right.
good. We're ready for you to keep moving on.
Okay.
and then I have this here, which is,
Okay.
and then
So
I tap it, and nothing happens with my servo, or if I put my hand in front of my,
all right, do you have
move-
so you have a servo plugged in and you have
Yeah.
a what's the other, what's your sensor?
distance sensor.
I'm sorry, can I hear you? Oh, it's distance. Okay. So you're gonna want to make sure that everything is plugged in correctly. Keep in mind the black wire, okay, needs to be negative. Okay. The red wire is going to be positive.
Red's negative, red's positive, and then yellow is S.
Yeah, and then yellow is going to be S. Okay.
Yes, I have that.
Okay. Now in your code, and it's a position servo.
Yeah,
Okay. And the devices are connected, right?
yes, my device is connected.
Okay. So, and you have the right port.
Yes,
Okay. So for your servo, all right, it's by default, it's probably at 90, right? Am I right?
Yeah.
Okay. So when you click on that block, okay, it's going to turn it to 90. Now, if the servo is already at 90 degrees, it's not going to turn. Does that make sense?
Okay,
Yeah,
yes,
because that's probably because it's already at 90 degrees. So try switching that to 0 and then click on it again.
still nothing's happening.
Okay. Now, do you have it's a position servo, right?
Yeah.
Okay. And you chose the position servo block?
Yeah.
Okay. And you're in the right port?
Yep. Or one. Or that.
Okay.
Mhm.
And your black, just to troubleshoot, so your black wire is
Wow,
lined up
okay.
with negative.
Yep. That was.
Now it is, you said?
Yeah.
All right. So I think that was the issue.
Yep.
Now give it a shot.
There we go.
All right, you got it. So no, and thank you. That's good. So what I just did is, right, I took you through a troubleshooting process, right? Because as you build things aren't going to work as they should. Okay.
Yeah, mine is working. Neither is mine.
Okay. So did you hear the troubleshooting process that we went through?
Sort of.
Okay. So first, let's test our board, right? I tell you what, Shippensburg, would you mind if we did this? Because I think Evans City is ready for the next step. So why don't we do this? Okay. Why don't we bring up bird blocks on our iPad? Okay. And then we can go over some of what we need to do as far as the coding. And then we can kind of come back and then we can troubleshoot. But I think you have something not plugged in correct. Okay. So like the other group, what I think you need to check is make sure the black wire, especially on your servo, make sure the black wire is lined up with negative. Okay. So we'll go over the next step and then we'll circle back if we need to troubleshoot. Okay. So I have the 3 blocks that I'm using. Right. So now I need to get this to happen automatically. Okay. So to do that, I'm going to go to my control panel here. I'm going to do an if else. Okay. And for mine, I'm going to put, because with the mouth, I had my LED shining all the time. So I'm just putting that up top so it shines. Okay. Within this if statement, okay, this is going to be if there is a shadow cast, okay, which means Buddy is being fed. So if there's a shadow cast, then I want the servo to turn, okay? Also, I should add that right now my servo is at 0 degrees. So what I'm going to do is I'm going to make 0 degrees. I'm going to make that my home. And that's where the eyes are open. And then 90 degrees is going to be where they're closed. Okay. So right now my servo is at 0. So I'm going to take my eyes and I'm just going to plug them in where they're and have them be visible right now. Okay. Which I have. Okay. So I'm going to take my position servo there. Now, I'm going to put it in that if statement. Now, I should probably, before I do that, I need to go to operators. And I'm going to do my less than block here. And that's going to go in there. Okay. Then it's saying 0 is less than 0. So I have to adjust these numbers. So in the first number, the first 0, this is where I'm putting my sensor block. Okay, so I want to say if the light sensor, oh, that should be light for me. So I'm going to say if the light sensor is detecting less than Now I need to set this number. So this is where it's useful for me to test the light level. So my range was from about 90 to 0. So 90 was when the LED was flashing on it. 0 was when I had a piece of food that I was feeding it. Okay. So I'm going to choose a number like kind of in the middle of 90 and 0. So about 45 or 50, I'm going to go with. So we'll do 45. Okay. Now, 0 is my home. 0 is eyes open, right? Let me show you here. So 0 is showing my eyes. So I want the eyes to shut. So basically when food is in its mouth, I want the eyes to close. So to do that, I'm going to switch that to 90. Okay. Now I'm going to get another servo. And again, I'm in port 2. So basically I'm saying like when it's being fed, close the eyes, turn it to 90. When it's not, we should be back home, which is eyes open, which I had set to 0. Okay. So now if I run this code, okay, and I need to do one other thing. So I went into control and I'm going to do a repeat forever block. So now when I block the light, my servo is going to turn. Okay. So
How do you do it for distance when you don't have like the bit LED?
I'm sorry, can you repeat that question?
How do you do it for distance? When you have a like a distance thing instead of a light, how do
Okay.
you do that?
Yep. So the question was, if you're using a distance sensor rather than a light, how would you do that? So let's talk about that. Okay, so here's my code. Okay, right now I have it set to a light sensor. So if I go to this drop down, I can choose distance, right? Again, make sure you have the right port. And then I'm going to say when something is less than a certain, and it goes by centimeters. Okay, so less than a certain number of centimeters away, then do something. I'd recommend like maybe 10 centimeters to maybe start out. But you can look at a ruler if you want, just to see what distance you want. When I've seen people use the distance center, or when I've used it, 10 centimeters seems to be the default. 10 centimeters should be maybe about that far away. Okay, you don't want to make this number for the distance sensor, you don't want to make it too big, or else it's going to pick up everything, or it's going to be so far away. So, and you can adjust that, like if you want something to be closer to it, maybe try 5. So that might be a little bit of trial and error, how far away you want something to be. All right, can I get some feedback, guys? How are we doing, Shippensburg and Evans City? So I just did a basic rotation with the sensor.
We're doing pretty good over here.
Okay, thank you.
We're doing okay.
Okay. I know this is a lot. It's okay. Keep in mind, we can, if we don't finish today, you can come back to it. All right, how about this? So in kind of the remaining time, I'm going to show you how we can even add to this code to make it better. So like if you remember, like Buddy at the beginning,
One person who's figured out how to do something.
okay?
He's gotten the arm on, which one is it? Position using the crank, the crank is moving. Using
Awesome.
turbo, so.
Awesome. Yeah, and
There's
I
one-
think, were you guys here for the first session that we did?
When was that?
It was a couple months ago or a month or two ago.
No,
Yeah.
we missed.
Yeah, so yeah, you guys are doing great. Like this is a more advanced project that we're doing. So we did a simpler one a couple months ago. So you guys are doing awesome.
Okay, great.
Okay. All right. So again, this is a simple rotation that I did with my servo. But if you remember Buddy at the beginning when we fed him, I don't know if you counted, but basically I had him blink 3 times and I had the tail wag 3 times. So let's go over how we can do that. Okay. So in order to do that, I'm in control and I'm going to need a repeat block here. And I'm going to make that repeat 3 times. Okay, but you can set it however many times that you want it to repeat. Okay. And what's going to happen, it's going to, remember 0, I set 0 as our home. 0 is, in the case of my eyes open. Okay. So I have that 0. 90 is closed. Okay. So what I need to happen is I'm going to need a pause. There we go. Or a wait block. And I'm not going to have it wait because I wanted to like blink real quickly. So I'm going to set this for like 0.3, 0.5 seconds or so. We'll say 0.3 seconds. And then I'm going to do another position servo rotation. This time I'm going to have it go from 90 degrees. So I'm going to have it turn 90 degrees, which is eyes shut. Then I'm going to have it turn back to open, which is 0 degrees. And the last thing, I need to put in a wait block after that. Again, I'm going to set that as 0.3. And now when let me run this. And if I block the light sensor, that's going to rotate it 3 times. Oh, wrong port. Now let's try it. Okay. So here, I'll bring up my camera so you can see what this looks like here. Okay, now whenever I block the light, so we're at 0, eyes open, and then it turns like that. So I'll leave that code up there, but that's how you can make you make something repeat. or make a servo motor turn back and forth, set number of times. And if you want to too, like if you have, you can actually take your camera on your iPad. If you want to take a picture of that code, then you can do that.
Here, we have a question over here.
So the distance sensor isn't working.
Okay.
It's supposed to activate motor whenever something comes close to it. And it's
Okay.
not working.
All right. So let's do some troubleshooting. One thing we might want to do. Okay, can you see my screen here? We'll try this first, okay? So I'm adding a when green flag is tapped. Okay, and you have a bit distance,
Yeah.
okay? And you have it, what number, less than what do you have it set as?
I have bit distance one.
Okay, I would increase that. Okay, because 1 centimeter that's not a lot of distance. Maybe try 5, let's try 10 to start. Okay, did you do that?
Yeah.
Okay. Now, are you having a servo rotate?
I had instead of bit position servo, I had bit rotation servo.
Okay, so you're turning a wheel, right?
Yeah.
Okay. So for that, in order to turn a wheel, what I think we'll need to do so I'm just taking out this for now. So let's look at your rotation servo block. Do you have it plugged into the right? Is it in port 1?
Yeah.
Okay. Your percentage, what percent do you have that rotating at?
100.
Okay, good. Yeah, have that at 100. And do you have a weight?
What?
Do you have a weight block after that?
No.
No? Okay. Put in a weight block. And actually, you probably, for the rotation servo, you probably won't need an if else. You could probably get away with so I'm going to kind of redo this here for you. I'm going to take out my LED too. So I'm just going to put these aside. I am putting it in a repeat forever. So we're going to do the distance, and then what we're going to do is basically kind of a more simple kind of code like that. Let's try that. So basically what this is saying is, when something is less than 10 centimeters away, we're going to turn on the rotation servo at full power. And right now I have it set for 1 second, but we can adjust that. Okay. Now, in order to start this, because I dragged in this block here, you're going to have to press that green flag. Okay, and then test it out. So let's see if that does what we need it to do.
Um, No, it's not.
Still not working. Okay. So let's troubleshoot. Did you get to when you just had this rotation servo block and you clicked on it, did your servo spin?
No.
It didn't? Okay. So I think the problem might be on our board then. Okay. So let's check our board. So if you look at your servo, if you look at the wire on it, you see how there's black, red, and white. Okay, and if we look at our servo ports, make sure that black wire is lined up with the minus sign, with negative. Remember, you had to click on the green flag to turn it on.
It's still not working.
Okay. So we have more things to check. Okay. I should also, before we get into more of the code and everything, are you connected? You see my screen here? Do you have that green button there?
Yeah.
Okay, so you're connected to your microbit. So let's check our sensor this time. So are you in sensor port 1, first of all?
Yeah.
Okay. Is your black wire in the negative hole for that?
Yeah.
Is your red wire in the positive one?
Yes.
Okay. And then the yellow one is in the S?
Yeah.
Okay. Now your power. Can we look at your power real quick? What color is that power light?
Orange.
It's orange. Okay. I'm pretty sure that might be our issue. Are those new batteries that we have, or are they older batteries?
We can probably just take it from another kit.
I think if it glows, doesn't that mean it's power?
It should, I don't know. If it's like a full functioning battery, what color should it be?
I believe green.
We have a green light, but we also have an orange light.
Okay, so your status is green.
Yeah, we have,
Okay.
yeah, status is green.
Okay. Let me just, if you give me a second here, let me double check my stuff here. When I did this, I did not use a rotation servo. So let me make sure that my code is correct. And I'm going to plug in a distance servo. So if you bear with me for a couple minutes,
Yeah, take your time.
I'm going to just kind of try to replicate what you have going. Just make sure that
Let's see.
while I'm doing this, another thing to maybe try is see if we can like try maybe rather than 10 centimeters, see if it'll work with like 20.
Nothing's happening with 20 either.
Okay. All right. I'm almost there. Let me grab a.
Yeah, take one of those ones.
Okay, my code seems to be okay. So I just got mine working with the code that I gave you.
Okay.
So let's maybe troubleshoot again. So if we can just go through a couple things here again, just double check. I know some of the stuff we checked again. So first of all, let's start with our distance sensor. Number one, can you verify that is all the wires are in port 1 for you?
It looks like they are.
Okay. Nothing's like accidentally in crossover with port 2 or anything?
No.
Okay. Can you try like giving it like a light tug on the wires? Is anything loose in there?
No, they're all pretty like secure in there.
Okay. And then let's just verify one more time. Is black in the negative port?
Black.
And again, sorry, I know we went through some of this stuff again. I'm just.
Oh, no, you're good.
Yep.
Here, we're gonna switch a few plugs. There we go, it worked.
So what was the issue?
We had one plug that wasn't in the negative.
Oh, okay. And was that on the distance sensor?
Yeah.
Okay. Yeah, and you know, this is and don't feel bad. This is all part of it. Just you know, whenever you're building a robot, whenever you're coding, things aren't going to go as planned all the time. So, you know, it's really important to have like a troubleshooting process and even double checking things and going over things one at a time again and again. So good job troubleshooting. Way to be patient. Because it can test your patience, it can get you upset, but you got to be calm and follow a process.
Yep, ours works now.
All right, good to hear. Awesome.
Thank you.
No, thank you. That's awesome. Okay, I think we're getting towards the end. I know I gave you a big project. But keep in mind, we can, if you're able, come back in. You can keep coming back to this and keep working on it. So hopefully I gave you enough though to let you run with it. So before we sign off, does anyone want to share their progress so far? All right, Micah, I think we're ready to sign off.
Yeah, sorry, we started mopping in the office, so my chair is now gone, but yeah, I think we're good. Obviously you guys are still free to keep working at your own pace. But we're gonna wrap up the Zoom here for the day. If you have any other questions, uh Chris's and I's email. So feel free to reach out, and then yeah, I guess we'll see the rest of the libraries next week.
Okay.
Yeah. All right. Have a good day, everybody. I'll talk to you guys when I see you next.